Assalamualaikum to my panel, Sir Amar Faiz and Sir Tg Mohd Faisal. Today I would like to present my PSM1. First of all, my name is Syahirah Binti Zamri from 3BEE. My project title is Development of Automated Full Body Scan CT Radiology Lung Cancer Analysis System.
Okay, as I mentioned before, my project title is Development of Automated Full Body Scan CT Radiology Lung Cancer Analysis System, and my supervisor is Khairul Azhar bin Aziz. Okay, I will start with the project background. As everyone knows, the most common cause of death worldwide is cancer. The mortality rate for lung cancer is high. Lung cancer is the disease that begin in the lungs. The diagnosis of lung cancer is important in human health in the uh, early stage. Computer topography is widely used for the providing electronic tissue density. Early stage lung cancer detection use the image processing technique. Okay, for a problem statement, full body CT scan, which was claimed to be costly as an approach to the identification of cancer and disease. If individuals are healthy, there are no point to proven benefit. The problem is to know how segment lung and segment lung cancer in correct way, and to know the output performance. Toughest thing to image processing task is to detect the real size of lesion. Okay, the objective for this project is to develop an automated full body CT scan image analysis system using image processing for lung cancer. Okay, next is to segment and classify lung from CT image, and lastly to analyze segmentation of lung cancer in CT scan image. Okay, next is a scope of the project. For modality, CT scan more effective compared to other modalities for lung cancer detection to convert an image into digital format and perform operation on it to get enhanced image or extract useful information is by using image processing technique. In the image processing technique, the image is import with an optical and or digital camera scanner, and the desired output image is analyzed and manipulated. Algorithm are used to clarify and enhance the image, then separate the region of interest for the whole image. MATLAB software used for image processing algorithm, but it is a low speed for implementing algorithm, must convert to any object-oriented programming language. Segmentation is important step which classification for radiological evolution. The goal segmentation of both lung is to extract lung mass from CT scan image with less time use. Then for dataset is using LIDC, which Lung Image Database Consortium, and this dataset has 1,000 CT scan of patient with lung cancer, and also provide information for diagnosis on each suspected lung nodule. Okay, we go to the literature review, which first medical scanning modalities such as CT scan, MRI, X-ray, and have their advantage and disadvantage. For CT scan advantage, low cost, more reliable, more efficient, and less noise. For CT scan disadvantage, have some difficulties, has poor image contrast. For MRI advantage, not use ionizing radiation for MRI image acquisition and non-invasive, which patient acceptability is high. Then for MRI disadvantage, only greater expertise is required for utilization MRI. For X-ray advantage, easy to handle and diagnose. And the disadvantage for X-ray is fail to detect normal two-dimensional and hard to detecting cancer stage. For the dataset, a lung image database consortium and image database resources, initiative, LIDC and IDRI acquired in DICOM format. 4 radiologists have annotated lung lesion by refer its size as nodule less than or equal to 3 mm. CT slice having thickness over than 2.5 mm were excluded. The cancer imaging achieved TCIA database of 377 non-small cell cancer at other clinic which treat with PD-1 inhibitor immunotherapy. 4 radiologists will use the LIDC set are detailed assign the malignancy by using source uh, between 1 until 5 is high. This is the example of the tumor location in 3 related dataset. Okay, we go to the segmentation. First is flow lung segmentation. The step is CT scan image, internal marker, external marker, then sober gradient, then watershed transform, and lastly is segmented lung. The internal and external marker of the scan are generated which basically act as a border of the lung. Since the border of lung is established, the remaining background area is removed, which is basic thresholding of the image. Watershed transform onto the resultant image which give the complete lung segmentation. Lung parenchyma is segment were obtained which must is used original image. Okay, next you can see the flow lung cancer segmentation. First is a lung CT image, then a lung segmentation using FCN. Next is lung nodule detection by binarization, lung nodule rough segmentation by level step method. Next, lastly is coordination transformation based population segmentation. This is as you can see the non-cancerous image and the and their segmentation issue and the cancerous image with their segmentation issue. For algorithm, according to Shazia Humera 2018, algorithm of lung segmentation was developed in the current work and accepted by 267 image of lung CT scan and their corresponding mask. Each image 128 multiple by 128 dimension. At the beginning of the process, by loading the dataset into memory, followed by rescaling each image size to 32 multiple by 32 dimension. For faster processing image rescaling necessary. This is show the list of algorithm step has been made in CT image to segment lung region. Okay, this is the comparison of lung detection CT scan image. There are several titles of journal that chose such as artificial neural network and fuzzy clustering. Lung cancer detection from CT scan using conventional neural network. Third journal is so close with this project, which detection of lung cancer in CT image using image processing. And last journal is lung cancer detection using image processing and machine learning healthcare. Okay, for first journal, which is using ANN and FCN, ANN learning process produce human lung. It can deal with the include nonlinear and complex data. FCM is regarded focus separate statement. Use program called degree C refer to another method. It can use an type of algorithm of the possibility can describe with the membership function of membership degrees. For second journal, by using conventional neural network, the 3D structures of nodule is used to extracting include by 3D CNN to predict lung cancer. Okay, by using CNN, the tedious task of manually extracting features can be dispensed with. The obtained precision and recall obtained for mode distance considering about that less label about the most state of art of system I use. So, focusing the third journal, according to the author, they says an image processing system has been successful, which to automatically detecting lung cancer in CT image, in improving segmenting and removing the characteristic of the adopted methodology. CT image medium filtering technique is compelling in order to eliminate pulse noise without blurring the image to more area. The last journal, we is using image processing and machine learning healthcare, according to the author, to create better access medical care and to make lung cancer detection system progressively strong. The system is using Java. Java were great in sense script line comparison and visualization, devising independent, thus they can operate the system at any place. This project are using threshold segmentation. Threshold approach has been widely used. In recent years, many genetic processing algorithm has been used to achieve the optimal threshold and have been implemented than conventional segmentation approach. Global and local threshold method include in threshold segmentation. Image processing, the global threshold is often used, which use the fixed threshold in the whole image. Gray histogram is the classic threshold selection processing object. Algorithms are used to clarify and enhance the image, then separate the region of interest from the whole image. MATLAB software is used for image processing algorithm, but it is low speed. So for implementing algorithm must convert to any object-oriented programming language. Segmentation is important step which classification for radiological evaluation. The goal segmentation of both lung is to extract a lung mass for CT scan image with less time use. For methodology, this figure show flowchart the segmentation of lung cancer for this project. Okay, start, insert image, any lung. If no lung, back to the start again. If yes, segment the lung, any cancer. If no, return back to the start. If yes, segment lung cancer, then output performance for lung segment, output performance cancer segment, then end the process. Okay, next is plot diagram postpose system of lung. First is image acquisition. All medical image are in DICOM standard format. DCM file extension is DICOM file format which for raw image of CT scan. The slice of image are arranged by refer to image can be extracted from the header of DICOM image. MATLAB focus is used to read the DICOM image. Next step is pre-processing. Have 5 steps, which is smoothing, used to remove noise from image. Next is enhancement, is way to improve image quality. Next is expand segmentation. Lung tissue lie among negative 700 HU and negative 600 HU. Threshold value is among negative 500 HU. Morphological opening is erosion, take place followed by dilation. Selection of ROI by using ROI where lung reduce and tumor found, and we perform operation to extract the features. Next is feature extraction, which include on each ROI to determine best features as best approach to extract features. Lastly, as classifier, which accuracy, sensitivity, specificity to calculate the performance of CT scan from dataset at IDC. Then compare the accuracy with the existing accurate method. For software requirement is MATLAB and ALIZA software. For MATLAB is high language which is for specialized processing, typically for utilize incorporate math calculation, algorithm advancement, simulation and others. MATLAB allows solving of numerous specialized issues. For ALIZA software is known as the Medical Imaging and DICOM Viewer. It lets users see in 2D, 3D, 4D image in DICOM. Effective way for segmentation algorithm which is carefully editing the combination of components. The segmentation does not include the overall set of acquisition parameter of the reference image such as cardiac pace. The result from ALIZA software will compare to the size obtained by MATLAB software. Next is performance measurement. This is the example of performance result. Performance measurement presents of detection performance depending upon nodule size. It shows that even the small nodule size have been a high success rate. Okay, next for the result. Okay, for MATLAB, the preliminary result. This is the example of image show in MATLAB, and this is the image resize. And next is the data cursor for both lung. Okay, for the ALIZA software preliminary result, this is present 2D lung image show by using the same image open in MATLAB. Next is expected result. By using the block diagram, it shows that they classify the segmentation. First, original DICOM image. Next, image processing and enhancement. Then, lung extraction and then detection of nodule. Next, segmentation of nodule. And lastly, segmentation of lung cancer. For commercialization relevancy, is specifically used for patients with lung cancer. By segment of lung cancer, it can determine the size of the lesion and its performance. It is easy to use and know its accuracy, suitable for medical field and may also perform other cancer applicable. The algorithm can be implemented for CAD software for cancer analysis. Okay, lastly for the conclusion of this project is automated full body CT scan image analysis system using image processing will successfully develop. Then will able to segment and classify lung from CT image, and lastly segmentation of lung cancer CT scan image will be performed.
That's all for my presentation. Thank you, sir, and have a nice day.